started already.
Do we run out of today? No, we have to do that. Oh, God, I have, I might be reading that. For a co-op event thing.
I love how he always has a bow tie.
It's a script. It's a real thing. Oh, yeah, we're on site. We're on site. How far are we hoping to get today on today's notes?
How far are we going to get today?
Yeah. Just because I'm running out halfway through.
I think we'll get through dictionaries, maybe halfway through into problem solving.
Are sets and
That's a pretty
dictionaries?
big one.
Are sets and dictionaries going to be on the midterm?
No, they're not going to be on the test.
Okay.
I do not test people on stuff that I cover the week of the test.
Yeah.
Because that's just me.
That is mean.
Yeah.
Okay.
I think that it's reasonable that you should have written an assignment on the stuff and seen the feedback from that assignment so you know what you did wrong, and et cetera, et cetera.
And you had like chances to work.
So is it gonna be like stuff from A1 and A2?
Correct.
Pretty much? Okay.
Yeah. Greetings. Hello. Test. Recording?
Yes.
Good. Hi, everybody. How's everybody doing today?
Good.
All getting ready for the test on Friday?
Not really, yes, sure.
I suppose everybody would like to know what's on the test on Friday. In general, Assignment 1 and Assignment 2 are the coverage material. If you know a little bit about lists, that can also help. Like, if you understand the tuple operations, then, you know, those that are also applicable to lists, that can also be useful for the bonus question. So if you study up on like your basic list operations, then that's a good thing. That will probably serve you well. But in general, things don't get much more complicated than the type of thing you saw in Assignment 2. Okay? Questions?
Will we be allowed to like Google up syntaxes during the test?
No, you will be provided with a syntax reference sheet.
Oh.
But as for, you do not have access to internet sources during the test.
Ooh.
Okay? Yes?
Can you show us like what's the syntax like?
Oh, it's already on Avenue.
Oh.
It is?
Yeah, under extra resources. So you can take a look. Yes?
Can you?
I'll print them out for you.
And this is in addition to the cheat sheet.
Yeah, this is in addition to a
Really?
double-sided crib sheet, which you can fill out with whatever information you feel is pertinent. If I may offer a bit of advice, because, I don't know, did you guys do crib sheets in high school?
Yeah,
Kind
but
of, not
I
really.
think it's zoomed out pretty much.
The writing of the crib sheet itself is an excellent. Are we recording?
Yeah.
Zoom out.
Oh,
It
okay.
could be.
Yeah, you kind of have to pay attention to that thing.
Yeah.
So,
Slack is down.
if you've never written a test with a crib sheet before, basically, it's a blank, you know, you just take a piece of printer paper, right? Regular 8.5 by 11 piece of paper. I don't want anybody coming in with Bristol board. You can write anything you like on it, front or back, you know, and if you want, you can like do it on a computer and make the font like super, super tiny, but no magnifying glasses allowed in the test, I'm afraid. Make sure it's not so small that you have difficulty reading it. Generally, the idea is that you want to summarize whatever points you think are going to be important on the test. in such a manner that you can easily find and use the information on the crib sheet. There has been a tendency in the past for people to share crib sheets with each other. While this is not technically illegal, shall we say, it does kind of defeat the purpose of the crib sheet, which is that you are the person who picks through all the information and finds what you believe to be relevant and puts it on there. Like, you know, it's like, by all means, it's like, oh, you put that on your crib sheet? Oh, maybe that's a good idea, and then you write it in, you know, that sort of thing. But to just copy someone else's crib sheet, like, without even reading it, kind of defeats its purpose as a study aid, right? So, my recommendation, definitely write your own cheat sheet. By all means, you know, take a look at your friend's cheat sheet, see what they're putting on there, see what you think is relevant, you know. Make a decision about the data that they're including, sort of thing, you know. Am I making myself clear?
Yes.
Cool. Question?
For the reference sheet that you were talking about earlier, there's like 3 of them. Which one are you getting? It says exam syntax reference sheet, and Python multiple syntax.
Yeah.
Oh,
The
the first one, like, for this one, or not the first one, the middle one.
okay.
That's the first one I did. So the thing about the ultimate written syntax reference sheet is it includes stuff from like much later in the course that's irrelevant at this point in time. So just the basic reference sheet is enough at this point in time.
The syntax reference sheet?
Syntax reference sheet, yeah. Make sense? Any other questions? Yes.
Wait, about the cheat sheet, like, are we allowed to bring one for this test, or
Are you allowed to bring what?
like, are we allowed to bring the cheat sheet for this test, or?
Yes. Yeah.
Oh.
The test on Friday. You are permitted one double-sided crib sheet.
Okay.
Make sense?
Okay.
Any other questions about the test?
So does that mean should we say look over assignment 1 and assignment 2 in detail?
I would recommend, certainly anything you got wrong on assignment 1 and 2, make sure you understand why you got it wrong, and you know, that you can come up with a more correct version than the stuff you got wrong on assignment 1 and 2. Number 1, practice is going to be important. I highly recommend doing some additional coding problem practice prior to the test, because one of the problems that seems to be a problem people have a lot of the time is speed. So make sure that you have routinized if statements and while loops that you can bang out programs reasonably quickly. I recommend going through the coding back problems and seeing, like, timing yourself, seeing how fast you can solve them. Most of the coding back problems should be applicable at this point. Let's see here. Coding that. Obviously, you want the Python stuff, not the Java stuff. Yep, I would say these first 6 are good ones to do. So practice, practice, practice. All right? You guys are computer science people, and my expectations are high. Okay? Well, to be fair, my expectations are also high of non-computer science people, because like a lot of them are trying to get a minor in computer science, and if you're doing a minor in computer science, you should also know how to program, so, you know. But yeah, speed matters, so, you know, make sure that you're good at it. All right? Question?
For the coverage on the test for assignment 1 and 2, does that include the bonus questions as well in terms of difficulty?
So when I say coverage, I mean topics rather than program difficulty. Because this is an in-person test and you have a small number of shorter questions to do in a limited amount of time, like On an assignment, we can give you a larger problem that you can really sink your teeth into. It's not as possible on a test, which is a much more time-limited kind of scenario. So I would say you're probably shooting for mid-level questions on assignments as being like your sort of target difficulty bracket, if that makes sense. But, you know, there's also a somewhat, you know, ephemeral relationship between a problem and what its like subjective difficulty value is as measured by a student. You know, like it really matters on what you're good at and, you know, what you've studied and how you've practiced and how your brain works and that sort of thing. Like, you know, question difficulty is kind of not an easy thing to measure, if that makes sense. But yeah, does that make sense? Any other questions? Yes?
So when we find ourselves doing this, how long should we be taking?
That's a good question. Well, I'll tell you that the test is an hour and a half, and there are 3 questions plus a bonus question. So to get full marks, you would need to be able to bang out 1 problem every half hour. With the coding back problems, I would expect people to be able to do the easy ones in 2 or 3 minutes because they're so damn easy. More complicated ones, like if you take 10 minutes to do a reasonably hard problem, that's good. So yeah, basically the way that it works with these questions, we do actually have a methodology for trying to ensure that you guys aren't completely overwhelmed by the questions, because you know it's really easy to just crush you. Like we're like giants and you guys are the ants, and it's really easy to accidentally step on you. Not to put too fine a points on it, but we have a methodology. The TAs write the tests themselves, and my goal is that the TAs should be able to write the test that I put in front of you guys in 1/3 to 1/4 of the amount of time that you guys have. And so if that's, if they take more time than that, then I think about making some of the questions a little shorter and stuff like that. So, there's a balancing act going on there. So that being said, the TAs are pretty good. But anyway, yeah, that's like a very old rule going back to math tests in general. The TA or the prof should be able to do it in 1/4 of the time that you guys do it. Make sense?
Fair enough.
Question?
Are there going to be test cases provided to us on the test?
There will be test cases provided to you on the test. If you squint your eyes, you may confuse yourself and imagine that you are actually writing an assignment. That's how similar the test is going to be to the assignments. Okay? Question? Yes. You'll have to have, okay. Very important note. You will be writing the test on your own personal computing device, which you will bring to the testing room. All right? Bring a charger. I made sure to get a room that had outlets, so nobody has any power failures. If you haven't done so already, ensure that you have the capability of filling out a Jupyter notebook on your own computer. If I see anybody opening up VS Code, I'm going to slap their wrists. You should have the local installation of Jupyter downloaded and installed, right? Because I'm not sure how good the router is in that room, if it's going to tolerate 200 people all talking to Jupyter all at once. So it might be slow, and if it's slow, you need to have Jupyter on your own system because no more time will be allocated. Okay? Question?
So we could get it from like the VSC code and just like go from there, or like does it have to be like on?
I literally just said if I see VS Code, I'm going to slap your wrists.
Oh, I was looking at
Yeah. Yes. You can submit it through either Jupyter Hub or through Avenue, both of the ways that we have available regularly. Again, the idea is that the completion and submission procedure is precisely the same as with an assignment. Question?
The local version of Jupyter Hub does host it in your browser.
Yeah. Yeah, it's, what it does is it launches a local host spoofed server, and then it logs into its own little server that it's running on your system. But yeah, local Jupyter does run through a browser in the same way that the remote Jupyter runs through a browser. So you'll also need a browser installed on your computer, but I don't think anybody's going to have a problem with that. Question?
So on the test, you will be testing your programs ourselves, or is it going to be like the assignment, or you have test cases?
You will have some test cases provided. I always encourage people to test outside of the given test cases, but it's a time-limited test, so they, it's a test of your development skills. Question? Oh yeah, scrap paper will be provided as well. Yeah. Nope. Just the syntax reference sheet and your crib sheet. Now, if you want to put solutions to your assignment problems on your crib sheet, then that's up to you. You can put whatever you want on it. I will tell you right now that, the questions are sufficiently distinct that no one piece of code that you wrote for your assignments will be directly copy-pastable. Okay? Yes?
Can we install Jupyter Hub on a remote server and connect to that?
Jupyter
Hub on a remote server.
I don't see what the advantage of that would be over having it locally.
I have a really weak laptop, but I just connect to my server instead.
I mean, even a potato should be able to run Jupyter. But, I mean, I guess if you're really, well, no, it's not controlled, or, I don't know. You know what, I'm going to have to talk to the PAs about that one. Shoot me an email. Okay. Unusual question. Yes? Does Jupyter Hub run Doom? Depends on your definition of Doom. If you mean the video game, yeah, it would probably be capable of it. If you mean Doom for all the students in this room, probably. Yes.
Do we need to consider edge cases by default, or only if it is explicitly stated?
You should always be considering edge cases all the time, including on tests.
But if there's like a function, will we be receiving an input that's out of its scope?
You do not, if you have an input to a function with a data type specified, you may assume that it's, the input received will be of that data type.
So for example, if we have like a logarithm function and the input is a negative, then the domain is undefined. So
If there are any ambiguities like this on the test, raise your hand, ask a TA, and we will clarify. If it should be sufficiently obvious, especially for this one. Question?
Sorry, I'm a bit confused about, you said you worked on VS Code, but I accessed my local through VS Code.
Why? I mean, you should just be able to launch Jupyter in a browser on your local machine and do it there. Right? Again, VS Code users get their wrists slapped.
But VS Code is easy to use.
Oh my God.
I like VS Code.
Jeez, this is a lot of questions. Question? That's not a question. Question? It used to. Sorry. It's just like it's too easy. You have to learn how to code like real men. which means coding on like as little as possible. Like if you don't understand the system, like you have to be able to be adaptable to systems other than VS Code. You're not going to get away with coding everything on VS Code for the rest of your careers. Yes, you may use Emacs. Yes. I mean, Anaconda is a distribution, not an IDE. It contains IDEs. I recommend Jupyter. Jupyter is included in Anaconda. Basically, so the reason that I'm saying you shouldn't use VS Code is because we're going to be watching your laptops to see if you're on anything other than Jupyter, and anything other than Jupyter is going to arouse suspicions of academic dishonesty. All right? That's the reason. So use Jupyter. Last question.
Can you give us some like recommended questions on the coding that we do?
All of them.
Okay, that works too.
There aren't that many, and you should be able to bang them out pretty quickly at this point.
So many.
All right, can we start the class now? Jeez. I even had this fun story about how I fell in a hole yesterday that I didn't get to. Yeah, okay. I stepped on a manhole cover that wasn't secured, and my foot like went right in, and like
your class actually starts.
like, see, if it had hit me a little lower, I probably could have broken my knee. So I'm going to be sending some facility services a tersely worded email later on today. Like in the States, you'd get sued for something like that, you know? Just because Americans are extremely litigious. That's the adjective. A person who likes to sue or involve people in legal processes is litigious. Anyway, so we were talking about sets. I recommended. What's so funny? Okay. Control yourselves, please. We were talking about sets. Sets are kind of obscure Python knowledge, and it's likely you won't actually sort of organically use them very much. However, they do have their uses, particularly if you're trying to do any simulation of higher level math. So, here is your set of basic set operations, so to speak. Sets are declared using curly braces. If you want to create a set with multiple elements, the elements are comma separated inside of a set. If you wish to declare a set that does not contain anything, then it is set with blank parentheses. You might be asking yourself why this is different than the way we denoted empty tuples and empty lists. An empty tuple is just, well, actually it's tuple with a thing and then comma in it, I think, so never mind. Or maybe that's a tuple containing one item. Anyway, lists for sure are just empty. An empty list is just empty square braces. So why would we use set with round braces after it to denote the empty set? Well, it turns out that the curly braces are also used to denote dictionaries. Dictionaries, who's heard of them? Fair number of you. Dictionaries are used much more frequently than sets, therefore they have syntactic priority according to the language's design. So, empty curly braces denotes an empty dictionary. So set kind of gets left out in the cold. We talked about union, we talked about intersection, we talked about difference, we talked about cardinality. You should be well familiar with the linear searching in operator. You can also perform this operation over sets. In addition, we have a few in-place or mutating operations. We have add, remove, and pop. Pop being in the sort of stack sense. Simply put, it just adds adds some element to a set, discard removes some element E from a set, and pop returns and removes some arbitrary element. Arbitrary but deterministic. That's kind of a weird concept to wrap your noodle around, arbitrary but deterministic. Essentially, the elements of a set will be popped in a particular order. That order is not determined by any mechanism intelligible to humans, but if you try to do it the same, if you try to pop all the elements from the same set more than once, it will give them to you in the same order. So another way of thinking about this is it's kind of like a random number generator that always uses the same seed. You guys know about random number generation? How many people don't know about random number generation? So computers are not capable of true randomness. Any random number, quote unquote, generated by a computer is actually a pseudo-random number. Essentially what happens is you take some base number, which is called the seed, you apply some convoluted formula to it, which essentially scrambles the bits in some, essentially, it's repeatable. If you give it the same seed each time, it'll give you the same random number each time, right? But the relationship between the number that comes out and the number that goes in is too complex for human beings to really understand. So it looks like it's random. Commonly, for random number generators, some system value which frequently changes is used as the seed, such as the system clock, right? So, if you're using Unix epoch time, for example, as the input seed to your random number generator, then every single second you have a new number, and, you might need something more than that, like an increment on how many times you've called the random number, added to it, or something like that, in order to account for the, generating multiple random numbers in a 1 second interval, but I digress. So, here are a couple of examples. It turns out that sets will discard any duplicate elements. So, one way that you can quickly and easily identify the unique elements inside of a set, or the unique elements inside of a list or a tuple or something, is to convert it to a set and then return the length of that set. So, for example, if we have some input list L and S is some set that is empty, for each element in L, S is equal to S union a set containing just that element that we have extracted using the for loop. Another way of stating this is that we can use the add operation. All right? But, of course, there is, in fact, an even easier way, which I'm about to show you. Python 3. If the list contains, or let's make it a string because it'll work that way too. My mother said to pick this one, and you are not it. So, if you convert this to a set, that is all of the unique characters inside of that string. Right? So, you can use this complicated mechanism by which you're, using for loops and stuff, or you could just, return set that thing, and then you're done. Questions? Yes?
What did oh no, I thought that was the result of like overall I was thinking about like this was like related with the like bonus fraction of 72, but I don't think it's something like that.
Okay. You have a question?
What do the set examples like
vertical bar character. So vertical bar didn't work for some reason?
Yeah, for some reason typer and I have syntax.
In
Maybe a VS Code issue.
You're using Python, like what version of Python are you using? Is that something they changed in the most recent release of Python for some reason?
I don't believe so. But they've started overloading those operators with other stuff. So it might have been something like that.
I wish they'd this is why C is better, because when I can teach C and it doesn't change, you know? Bloody hell. I don't know. Well, I can tell you that I'm going to try it right now. We'll hit say step 1. Well, I already did it. I just did it last class and it worked. So
Yeah.
what's my friggin' Python version?
3.8. Dash version.
Dash version. Thank you. Yeah, 3.8.10. That's the most current, right? No?
3.10.5.
3.10.
Might be 3.11 by now. But this should still work.
Bloody hell. Anyway, skip that because we talked so long about the test. So, in summary so far, we've discussed technically 4 because strings count, but 3 different data structures. Tuples, round braces, duplicates are allowed, the order matters, and they are immutable. Lists, square braces, duplicates are allowed, order matters, and they are mutable. Sets, curly braces, no duplicates, order doesn't matter, and they are mutable. So what does it mean when we say order doesn't matter? It means that the elements of a set are not accessible using linear indexing. So, for example, if I have a set, 1, 2, 3, 4, 5, there we go. S at 2 is a type error. Set object is not subscriptable. So, if you can't even read this data structure using linear indexing, you can bet your bottom dollar that you also can't assign to it using linear indexing. Question?
How does it maintain the order when you print it out?
I don't know.
It does it for some reason, but it's not guaranteed to maintain it.
That's the answer. So like, if I had S and I was adding elements to it, at the moment it's adding them to the back, but you know, whether or not it does that every time is, you know, again, yeah. This isn't a good example, but it's not guaranteed to do that. So you can't assume that it does that. Question?
Earlier when you did the set string command example, it just kind of put the characters in the string in like a random order.
That's true. Yeah, actually. Thank you for that. Yeah, so if we go back to this example where we had the string, right?
Oh, pick it over.
The set conversion of that, the ordering of the letters in this guy bears like very little resemblance to the ordering of the characters in the original string, right? So if what it was doing is adding these one by one in the manner up here, this would, you know, look like this, but instead it just ends up kind of random. Make sense? Question?
In what cases, like, do we use sets?
What cases do you use sets? Next question. They're not as useful. If you are given a problem related to set theory and you want to, like, do specific things that are set theory related, but the problem with that, of course, is that, you know, most other data types, more useful data types, can be hammered into set operations, you know. Like, there's no reason you can't perform union on lists, right? The only property which might be useful is that sets don't maintain duplicates. But again, can I just say I hate Python and we can move on?
Oh, yeah.
Okay. Okay, good. Other languages do this type of thing much better than Python does. Haskell comes to mind. Haskell does sets very well. So if you want to take a look at that. See, the reasons Haskell does this way better than Python is that, unlike Python, Haskell is strongly statically typed, right? So when you say, I am creating a set that can contain this, or that, that's actually enforced at the level of the type checker, right? So if you try to return an element that's not in that set when it's expecting one in that set, that will fail to compile, which is useful because it means that Haskell is protecting its own abstractions, whereas Python does not protect its own abstractions. Python seems to think that by making things loose and, you know, dynamic and all of this thing, that it's actually making things easier, but all it's doing is compensating for sort of less rigorous thinking on the part of the programmer, right? Like, if you're a rigorous programmer who knows how to use data types and can program well, Python is a very annoying language to program in. Technically speaking, a good Python programmer programs as well as anybody else in any other language, but it's just, it really sort of, I think, falls down when you start getting into like the intermediate level of programming, where you start needing to rely on the language to do these types of checks, you know? Question?
I just wanted to comment that sublinters have kind of sort of static type checking in Python.
The which is, sorry?
Sublinters have it.
Some linters, what?
Yeah. So there's, I believe it's called Pilot, which has static typing, which you can enable in options, which imports it before you run it.
Yeah. I don't know, it always feels like something tacked on the side. Like, you also have type annotations, which Mark often uses for assignment solutions and that sort of thing. Type annotations, like the regular type annotations, aren't binding. So, you know, I don't know. I'd take a strongly statically typed language any day, personally. Yes. Python is a language that was made for lazy brains. So anyway, so that's about as much as I have to say about sets. I'd like to now move on to dictionaries, which are much more useful. So, you guys in 1DM3 right now, or is that next semester? I always forget. Okay. Well, I'll give you a slight preview then, because it mathematically explains what a dictionary even is. So we talked about sets, right? A set is a collection of objects, right? The integers are a set, the booleans are a set, characters are a set, even though Python pretends they're not. All kinds of stuff like that. What a dictionary is, in formal mathematical terms, is a mapping between one set and another. Another way of saying this is that it is a relation. When you get into 1DM3, you will talk about sets, relations, functions, properties of relations, all of these types of things. So essentially, what a dictionary allows you to do is go from one element of an arbitrary set to another element of another arbitrary set. Another way of thinking about this, it's kind of like a list, except rather than just using the natural numbers as indexes, you can use anything as an index so long as it's, not too complicated. I believe you can't use mutable data structures as indexes for dictionaries, but you can use things like tuples because they're immutable. I have to test that though. So, for example, lists, strings, tuples, and tuples are indexed by integers. Dictionaries can be indexed by arbitrary types. So, for example, if we have a dictionary containing the days in the month of the year, we may map from a 3-character string denoting the month abbreviation to an integer representing the number of days in that month of the year, excluding leap years, of course. Make sense? It turns out that dictionaries are like the second most useful data structure underneath lists in Python. So, the manner in which you access the elements of a dictionary is by specifying as the index, one of these, what are called key values. All right? Or key values is kind of not the way you want to say it because they're key value pairs. So this is a key, right? It looks up this key and returns this value. These are key value pairs. Question?
And the order of dictionaries, like, it doesn't matter, right? The order.
Correct. Similarly to sets, the order in which these elements appear in the dictionary does not matter. You do not access them via linear indexing, right? If you just put like 2 here, it would say key error, 2 does not exist in the dictionary, right? It's not looking these up as if they were in sequence. It's looking them up by their keys, right? So, that being said, it is possible to construct a dictionary that uses 0, 1, 2, 3, and 4, etc. as the keys. Although if you were going to do that, I don't know why you wouldn't use a list instead. Yes?
Then, like, what if, like, the key is duplicated? Like, does it work?
Dictionaries are not permitted to have duplicate keys. Values may be duplicated, but keys must be unique. Question?
Does Python have enumeration? Or is enumeration different from this?
I'm not sure if Python has enumeration. Pretty much everything has enumeration, so I would be surprised if it didn't, but I actually don't know. I'd have to look it up. It's a little bit like enumeration, but not quite. Yes?
Do you hate Java more than Python?
Do I need what?
Do you hate Java more than Python?
No.
Is it your worst programming language?
Yeah, Java is my most hated language, aside from like esoteric languages. If you want to have some fun this week, look up the Wikipedia page on esoteric programming languages.
Wait, so you just said that you constantly hate Java more than Python?
I do not hate Java more than Python. Java is like when I make fun of Java, it's like I'm making fun of an old man for being old. It's kind of in a good-natured way. I genuinely hate how Python does a lot of things, right? Also, me hating particular programming languages, I kind of play it up for comedic effect a little bit, But Python does do some things genuinely terribly. Just wait till we get to object-oriented, man. Just wait. So, dictionaries contain key value pairs. The thing that we index with is called the key. The thing that is being accessed via the index is called the value. Very important nomenclature that will follow you through to studying hash tables and that sort of thing. If you know what a hash table is, It's a little bit like a hash table. So, operations. As previously mentioned, empty curly braces have been reserved for use by empty dictionaries. To populate a dictionary with values upon creation, you simply place key-value pairs, which are colon separated, in a comma-separated list inside of the curly braces. Right? Item lookup inside of a dictionary uses the same square brace indexing operation that we're used to by now. Could you keep it to a dull roar, please? Shh. Thank you. We have the same searching operation that we have regularly. Deletion uses the del keyword. This is slightly different. Size can be determined by length, of course, and these two are interesting and more frequently used than you might think. Dot keys and dot values. These return a tuple containing just the keys and just the values of the dictionary. Now, this is interesting. This one is probably going to be less used for you guys than values, because the in operator searches keys by default, not values. So when you say is key in dictionary, right, if you say X in dictionary, it's looking at the keys to tell you if it's in there or not, right? Values, it's occasionally useful to look through the values to see if something is in there or not, right? So that, that's useful. Any questions so far? So, dictionaries are mutable in the same sense as lists. If you provide an index, or if you provide a key, you can perform assignment through that mechanism. And you may have noticed on the previous slide, we didn't have any listed way to add elements to a dictionary. The way that you add an element to a dictionary, you simply assign to an unused key. That will add that key and the value that you're assigning to the dictionary as new elements. Yes? Sorry, you first.
Okay. So, you have like CO1, CO2, but it's not like guaranteed that they always be in like that order, right? So we could add CO3 to go in the middle.
Yeah, you shouldn't think about order as a thing that exists in dictionaries. Question?
Why does it like return the value of like, oh, is it changing the value for the normal CO1?
Yeah, that's an assignment statement.
Oh, nice.
So, yes, this will update the count here to 47, this line. This line will update the count here to 154. This line will add a third element to the dictionary, a third pair to the dictionary, mapping from CO3 to 0. Question?
Can you repeat the stuff that you're talking about adding the dictionary? I just didn't get that. I just didn't catch that.
So, we did not have a specific operation for adding a new pair to a dictionary.
Yeah.
The reason is because it's being loaded on assignment. So if you assign to an unused key in the dictionary, that will create a new pair inside of the inside of the data structure.
Okay.
All right? Does that make sense?
Yep.
Any other questions? Yes.
Do the values have to be the same type?
No. They can be different. They can be Python. They can be anything you like, including other dictionaries. And you can mix and match. You can have them return beets and carrots and cats and dogs. You can have them return you know, anything. Any other questions? So, yeah, okay, we'll do this next time. Class is dismissed.